Dear students, let us discuss the second problem in ladder friction in this lecture video. A 7-meter long ladder rests against a vertical wall with which it makes an angle of 45 degrees and on a floor. If a man whose weight is half of the weight of the ladder climbs on the ladder, at what distance along the ladder will he be? The ladder will be about to slip. Take the coefficient of friction between the ladder and the wall is 1/3 and that between the ladder and the floor is 1/2. Data given in the problem. In the problem, the considered ladder rests against a vertical wall. The length of the ladder is given as 7 meter. So its weight will be considered at the center point of the ladder, that is at the distance of 7/2, that is 3.5 meter from either end. The weight of the ladder will be considered. Okay. The coefficient of friction between the top of the ladder and the wall is given as mu p is equal to 1/3, and the coefficient of friction between the foot of the ladder and the floor is given as mu a is equal to 1/2. In the problem, it is given that when a man of weight equals to half of the weight of the ladder, W/2, stands on the ladder at a particular distance from the foot of the ladder, we can consider that distance as x. The ladder is about to slide. Okay. We need to calculate for the impending motion of the ladder what will be the distance x at which the man is standing on the ladder. Here at the contact point B, there will be a normal reaction force to be considered, that is NB. Here at point A also, normal to the plane, a normal reaction force NA will be considered. Okay. When the ladder is about to slide, it will slide in this direction. So the frictional force at point A will be acting in the opposite direction of the motion of the ladder. So the direction of the frictional force will be in the positive x-axis direction. Okay. Similarly, when the ladder is about to slide, the top of the ladder will slide on the wall in this direction. So at point B, the frictional force will be acting in the opposite direction of the motion of the ladder. So FB, frictional force, will be acting in the positive y-axis direction. When the ladder is about to slide for the subjected loading condition, the state of motion of the ladder is known to be impending motion. Up to that instant, the ladder will be in equilibrium condition. So we can solve this problem by applying equilibrium conditions. Okay. First, considering all the horizontal forces acting on the ladder, the first equilibrium condition is summation of all the horizontal forces acting on the ladder is 0. Here, this force FA is acting on the ladder in the positive x-axis direction, so plus FA. Here, NB is the normal reaction force acting at point B in the negative x-axis direction, so minus NB is equal to 0. Okay. The formula for the frictional force component F is mu into normal reaction force. So here mu A into NA minus NB is equal to 0. Okay. The value of mu A is given in the problem as 1/2. So this becomes 1/2 NA is equal to NB, or NA is equal to 2 NB. We can keep this as equation 1. Next, considering the second equilibrium condition, that is summation of all the vertical forces acting on the ladder at the instant is equal to 0. Considering the vertical forces, here NA and FP, these two force components are acting on the ladder in the positive y-axis direction. So NA plus FB, weight of the ladder and weight of the man, these two force components are acting on the ladder in the negative y-axis direction. So minus W minus W/2 is equal to 0. This becomes NA plus the frictional force component formula is mu into N, that is normal reaction. So FB is mu B into NB. By taking minus in the outside, this will be W plus W/2 is equal to 0. NA plus mu B value is given in the problem as 1/3 this will be minus 3w by 2 is equal to 0. We can keep this as equation 2. Okay. Now we can substitute equation 1 in equation 2. Equation 1 is NA is equal to 2NB. So equation 2 becomes NA is 2NB plus 1 by 3 NB minus 3W by 2 is equal to 0. So this is 2 plus 1 by 3 NB minus 3W by 2 is equal to 0. 2 plus 1 by 3 is 7 by 3. So 7 by 3 NB minus 3W by 2 is equal to 0. This becomes 7 by 3 NB is equal to 3W by 2. So NB is 3W by 2 into 3 by 7. This is 9 by 14 W. And from equation 1, NA is equal to 2NB. So 2 into this NB is 9 by 14 W. So NA will be 9 by 7 W. We can keep this as equation 3 and this as equation 4. Now considering the third equilibrium condition, that is summation of the moments of all the forces acting at point A is equal to 0. Here the frictional force acting at point B, normal reaction at point B, weight of the man W by 2, weight of the ladder W, frictional force acting at point A and the normal reaction force acting at point A. These all force components are to be considered for calculating the summation of the moments of all the forces acting at point A. But here the frictional force acting at point A and the normal reaction force acting at point A will not generate any moment at point A because these two force components are acting at that point itself. There will be no perpendicular distance between the location of this force components and point A. So we can neglect these two force components while calculating the moments of the forces at point A. So we need to consider these four force components for calculating summation MA. Considering the NB force component, this force is having anti-clockwise rotation about point A. So the sign is plus NB into the perpendicular distance between the location of the force component NB and point A is BC. Next, considering this force component FB, this FB force component is having anti-clockwise rotation about point A, so plus FB into the perpendicular distance between the location of FB and point A is AC. Next, considering weight of the man W by 2, this force component is having clockwise rotation about point A, so the sign is minus W by 2 into the perpendicular distance between the location of this force component W by 2 and point A is AD. Next, considering the force component weight of the ladder about point A, weight of the ladder is having clockwise rotation, so the sign is minus W into the perpendicular distance between the location of the weight of the ladder and point A is AE is equal to 0. Okay. So to apply the third equilibrium condition, we need to calculate the perpendicular distances BC, AC, AD and AE. To calculate BC, this is BC. By considering this right angle triangle, we can calculate the value of BC by considering the trigonometric relationship for sine 45 degree is equal to the opposite side BC divided by hypotenuse Hypotenuse for the considered right angle triangle as the length of the ladder, that is 7 meter. So BC is 7 sine 45 degree, that is 4.9497 meter. Okay. Next, to calculate the perpendicular distance AC, again by considering this right angle triangle, for the trigonometric relationship for cosine, we can calculate the perpendicular distance AC. Okay. Cos 45 degree is equal to the adjacent side AC divided by hypotenuse of the right angle triangle 7 meter. So AC is equal to 7 cos 45 degree, which is also 4.9497 meter. Okay. Next, to calculate the perpendicular distance AD, by considering this right angle triangle, using trigonometric relationship for cosine, we can calculate the perpendicular distance AD. Here also cos 45 degree is equal to the adjacent side of the right angle triangle AD divided by the hypotenuse of this right angle triangle as this x. So AD is equal to x cos 45 degree. This is 0.7071x. Next, to calculate the distance AE, by considering this right angle triangle, we can use the trigonometric relationship for cosine. We can calculate the distance AE as cos 45 degree is equal to the adjacent side is AE divided by the hypotenuse is 3.5 meter. Okay. So AE is equal to 3.5 cos 45 degree is equal to 2.4749 meter. Okay. Now summation MA is equal to, already we have expressed the summation of moments of all the forces about point A, that is plus NB into BC. BC we have calculated as 4.9497 plus FB into AC, that is 4.9497 minus W by 2 into AD. AD is 0.7071x minus W into AE. AE is 2.4749 meter is equal to 0. Okay. This FB is mu B into NB. Mu B value is given in the problem as 1 by 3. So this becomes 1 by 3 NB. So the above expression can be simplified as 4.9497 NB plus 1 by 3 into this 4.9497 is 1.6499 NB minus W by 2 into 0.7071x is minus 0.3536 Wx minus 2.4749 W is equal to 0. This can be simplified as 6.5996 NB minus 0.3536 Wx minus 2.4749 W is equal to 0. We can keep this as equation 5. Now we can substitute equation 3 in equation 5. Equation 3 is NB is equal to 9 by 14 W. So equation 5 becomes 6.5996 into 9 by 14 W minus 0.3536 into Wx minus 2.4749 into W is equal to 0. This is 4.2426 W minus 0.3536 Wx minus 2.4749 W is equal to 0. So this can be simplified as 1.7677 W minus 0.3536 Wx is equal to 0. Therefore, 0.3536 Wx is equal to 1.7677 W. You can cancel the W term in both the sides. So we can get the value of X as 1.7677 divided by 0.3536 as 5 meter. Okay.